Welcome to this Morphit demonstration. Today I want to demonstrate how we can use Morphit to analyse data from multiple data sources. My name is Ted Hawkins and I'm from the Edge Software Consultancy. So the objectives in this demonstration are to identify selectively active hits that have been recorded in a number of screens. And of course the second part of this is to demonstrate how we can access the multiple data sources for the analysis. The process we'll follow is quite simple. We will start this process as an experiment within BioRails. We'll open a document and retrieve the results into a Morphit document. We then set the threshold of activity, say 90% or the 85% that we're interested in. This will identify the collection of selective hits, and then we'll retrieve compound data from a different database. We then return the results as results into BioRails and complete the experiment. We're going to run this analysis using an experiment in BioRails, and in this way we can record the results of the analysis as results. As we're using a Morphit binder, it makes sense to use the BioRails Explorer, which is the desktop integration with Windows. So we have to log in, and BioRails will then connect, or BioRails Explorer. Okay, so this is opened up. I'll select my home folder. And what we're going to do is create an experiment. So we provide a unique identifier. And select the method. Now this will create the experiment in BioRails and download any content through the Explorer. So in this way we can deploy the binder to the user without them to worry about opening specific templates. So let's open that Morphit binder. And here we have the empty binder. There's no data in it. There's no work been done yet. So the first thing to do is to retrieve the results for the compounds that have been tested in BioRails. And to do this, we're actually linking to a BioRails query, a query that's been designed by myself in BioRails, and we're simply going to access it. So this has downloaded around 6,000 rows of data, and it's importing them into the data table and also running the canned analysis that's within the binder. So here's the data. We can see that it's across multiple experiments and experiment steps, or what we call tasks. We're storing the receptor and the concentration of each of the results, because these are grouped across all the compounds of the plate, and we can see for each compound its inhibition. If we look at the hit profile, what this has done is identified all the compounds which have an activity in any of the receptors above the threshold. So this crosstab here has also been highlighted with conditional formatting to show the hits, and we can also show the misses. Now we can change this threshold. And by lowering the threshold we'd expect to see perhaps more hits, and we do, and we can also see their profiles. Now, just to demonstrate the graphing capability, we've got here the proportion of the hits, and if we change the threshold, we can see that we see the proportion of hits over each of the receptors. Okay, so what we've done here is extracted only the compounds that are active on a single receptor. So if we look on here, ESC000202, ESC00202 is only active at the 5-HT2B receptor. Okay, so before we return the results, we might want to actually look at the structure and know, for example, if there are any of this compound left. So we've got another query built in here for compounds. If we press this, this will basically run a query against a different database and retrieve the extra information just for these compounds. So in this case, we can see we have the structural information, we've retrieved the molecular weight, and we've also retrieved the quantity of the compound. And the quantities actually works across all of the batches. The final stage is to post this results back up to BioRails. Now I could have added a checkbox as a final approval step, but we'll just post these as a set of selective hits. So these will update the parent task in BioRails, and this data will now be available for querying. So we could have saved the binder as well, but before we finish, I just want to highlight how the queries are built within the system. So in this case, we have a hidden sheet called compounds. We can see here all the compounds. Now these compounds here are provided from essentially the list of compounds that appear here. So there is a named range of a unique set of compounds. If we look on this table, we can see that there is a query linked to it, and if we edit this, this will open the query builder that's built into Morphit. So we would need to connect, and we can see here we're connecting to a MySQL database. It's held locally, but we could have connected to Oracle or Access or SQL Server and so on. When it connects, it reads all the tables and all the foreign keys and so on, and we can either build the query through the expression builder, or actually by editing the text box held beneath. The query is restricted by an in clause, and we can see there on the tooltip that there is let's just widen that up, that there is a referral to the named range. So what this says is, if the compounds are in, the @ means an array, the nr means named range, and it's text based, and the named range is called hits, and this is what limits the return values. Okay, so if for example we go back to our threshold and we drop the threshold again, we know that we get more compounds, but if we look at our selective hits, we can see we don't have the extra data for these compounds, so we can go and retrieve it. And obviously we could have tied in the retrieval of the extra data to the button click for the threshold, but I want to simplify the demonstration. Okay, so that completes the demonstration of Morphit. We'll close this down. We don't need to save that. And if we look in here, we'll see that if we preview the experiment, we can see the results have been returned back to Morphit, to BioRails as structured data. And normally go into BioRails and add any annotations and complete the experiment. Okay, that's the end of the demonstration. Thank you.